Finding the maxima and minima with the method of Lagrange multipliers is a way to find the maxima or the minima of a function that has a constraint to it. So the constraint, which would be g of x, must be equal to 0. And it is a system of solutions used to find that maxima and the minima. So for this example, for a rectangle whose perimeter is 20 meters, find the dimensions that will maximize the area. The first thing we must do is determine what the f of x is and what the g of x is. So drawing out a diagram and labeling the sides, x and y. To find the area, we know area is length times width. So therefore, since we are trying to find what maximizes the area here, f of x, y is x times y. To find the perimeter, it's going to be adding up all the sides. So it's going to be 2x plus 2y, which the problem tells us is 20 meters, equals 20 meters. So this is the constraint. The perimeter has to be 20 meters. So this is our g of x. And it must be equal to 0. So the first step we're going to do is finding f of x and g of x, which we already did here. So f of x is equal to x, y. G of x is equal to 2x plus 2y equals 20 meters. Then we need to make this equal to 0. By doing that, it's going to be 2x plus 2y minus 20 meters is equal to 0. Our next step we're going to do is we're going to find x, y, and lambda. The way we do this is by using this formula here. So f of x, y is equal to f x, y plus lambda times g of x. We use up here, we're going to plug this here in for this, and we're going to plug this here into here. So this becomes xy plus lambda times 2x plus 2y minus 20. Then we're going to simplify it, which would be xy plus 2x lambda plus 2y lambda minus 20 lambda. In the next step, we're going to find the derivative with respect to x, y, and lambda. So we're going to find the derivative of this equation here with respect to each of these. So the derivative with respect to x would be y plus two lambda. Everything else would go to 0. F of y would be x plus 2 lambda, and everything else would go to 0. And the derivative with respect to lambda, the xy would go to 0. It would be 2x plus 2y minus 20. Next, we're going to solve for x, y, and lambda using algebra. So first, we're going to do y plus 2 lambda equals 0, which would go to y equals negative 2 lambda. X plus 2 lambda would go to x equals negative 2 lambda. And then we're going to take each of these here and plug them into this formula. So we're going to go 2 times negative 2 lambda plus 2 times negative 2 lambda minus 20 equals 0. And we're going to solve for lambda. So it's going to be negative 4 lambda minus 4 lambda equals 20. So it's going to be negative 8 lambda equals 20. Divide both sides by negative 8. And lambda equals negative 2.5. Now, we're going to plug this negative 2.5 back into y equals negative 2 lambda. So y equals negative 2 times negative 2.5. So y equals 5. Same for x. x equals -2 times -2.5, x equals 5. So what this means is the dimensions that will maximize the area